Hi everyone, and welcome to the Public Interest Technology PIC Colloquium. My name is Roba Abbas, and I am a visiting professor at Arizona State University School for the Future of Innovation in Society and a senior lecturer in the School of Business at the University of Wollongong, Australia. Together with the director of the Society Policy Engineering Collective, Professor Katina Michael, we are bringing you another session in Series 3 of our colloquium. We would like to acknowledge and thank our colleagues Melissa Waite and Anna Reid, as usual, for their logistical, marketing and communications support. As we've heard throughout this series, the Public Interest Technology Colloquium is an opportunity to hear from our global community about the social, regulatory, and ethical considerations relevant to the design, development, and delivery of technology in the public interest. So the colloquium is underpinned by the public interest technology philosophy that is intended to draw people together from across disciplines and to address global challenges. Public interest technology at its core requires shared meaning, which is translational. It is to be inclusive rather than exclusive. And it's also to be transdisciplinary while respecting the disciplines. We would like to welcome our guests for today, Associate Professor Shahriar Akter, Professor Olivera Marianovich, and Associate Professor Patrick Mikalef. In this session, we're somewhat continuing from the discussion from last week and considering various facets relating to artificial intelligence and the public interest. Our specific theme for today is algorithmic bias, justice, and governance. Each of our wonderful speakers will be merely scratching the surface in terms of coverage of their respective topics within the designated time. And as such, we recommend that you also refer to their publications for more information about their research and projects. And to our live attendees today, as always, please feel free to write your questions and reflections in the chat as we go through each of the presentations, and we may have the opportunity for questions at the conclusion of the 3 presentations. I would like to welcome our first speaker, Associate Professor Shahriar Akter. Shahriar Akter is an Associate Professor of Digital Marketing Analytics and Innovation at the School of Business at the University of Wollongong, Australia. He's an Associate Editor of the Journal of Strategic Marketing, and he was also awarded his PhD from the University of New South Wales Business School with a doctoral fellowship in research methods from the University of Oxford. He has published in leading business journals with over 50 A or A star ranked articles in the ABDC list with over 100 publications. He's also one of the top 2% scholars according to the 2021 Stanford University rankings and Elsevier. His current H-index is 36 with more than 9,000 citations. He is also on the editorial boards of the Electronic Markets and the International Journal of Information Management. Shahriar is also a visiting professor at the Toulouse Business School in France and the University of Michigan Shanghai Jiao Tong University Joint Institute in China. Today, Associate Professor Shahriar Akter will present on the topic of algorithmic bias in machine learning-based models, introducing a framework that identifies the sources of algorithmic bias in marketing, drawing on the microfoundations of dynamic capability. Welcome, Shahriar, to our colloquium, and thank you for joining us for this session.
Thank you very much, Roba, for your excellent introduction. So it's my great pleasure and privilege to present in front of esteemed audiences and talk about my research. So let's get started with my presentation. So we have been doing research on algorithmic bias in the last 3 years. So we have in our team, Katina is also an esteemed collaborator in our research team. And I have got some other colleagues and PhD students who are all doing research on this area. So as part of this algorithmic bias in marketing models, today I'm going to basically talk about what we have done as of now and what is its future. And basically, because I am representing marketing discipline, I'm going to discuss more about marketing implications of this. If we look at this, so is it still in the presenter mode or no? Okay, great. So if we look at the phases of industrial revolution, then here you see the first industrial revolution focused on steam engine. The second one focused on electricity. The third one focused on automation, microelectronics. And in the third industrial revolution, we have seen a lot of Southeast Asian countries who are very good in this have come up on the top of the economic surface in the world, for example, Taiwan, Malaysia, Singapore. But now we are in Industry 4.0 or in the fourth industrial revolution, and we say it's the fusion of AI, cloud, analytics, IoT, and blockchain. So we are in this fourth industrial revolution, and this fourth industrial revolution is basically making all of us nervous. How can we get advantage of this revolution? How can we use this revolution for the benefit of everyone? Now, if we look back at algorithms in the early computing, then we know that AI was coined by John McCarthy at Stanford University back in 1952. And he basically defined this as the science and engineering of making intelligent machines. On the other side of the Atlantic, we have got Alan Turing. He was basically working on intelligent machines. So he was basically trying to feed lots and lots of data to a machine and trying to make machines think. So if we look at programming, then there are two ways we can program a machine. One is called a recipe. We give this and that and ask machines, do this, do that. There is one way of programming a machine. And the other way of programming a machine is basically feeding lots and lots of data and asking machine to learn the pattern and working on that pattern. Now, that is basically the Alan Turing's idea, right? Now, all those great AI foundation forefathers, they were basically working on these two ways of developing artificial intelligence. If we look at the recent changes, then in the last 20 years, if we look at what is happening in the internet world, then every single minute we have got this amount of logs in Facebook, 2.4 million search queries in Google, 150 million emails are sent, and the mighty Amazon, it makes basically $200 per minute. So if Amazon were a country, it would have been one of the 58th richest country of the world. It has got an income which is more than countries like Algeria, Tunisia. So it has got that amount of income. Now, this is a data-driven economy. If we go back to internet and its development, here you can see the artificial intelligence back in 50s and 60s, it was developed. The theories were developed, the equations were developed, but it didn't progress further because at that time we didn't have data. The difference is that in the last 20 years, we have got so much of data, and we are going back to Alan Turing's idea, feeding machines lots and lots of data and asking machines to think like a human. So as part of this, now we have got two different types of applications of artificial intelligence. One is machine learning, and the other one is deep learning. Now, if we go back to machine learning, then here you see, in case of machine learning, we are asking machines, these are the attributes, and based on these attributes, classify the data. And that is basically, for example, in marketing, I apply this technique in churn analytics. I ask machines to identify which customers out of 100,000 customers are going to switch. For example, in case of Telstra, which customers are going to switch, or which customers are going to leave us by next 2 or 3 months. Woolworths is applying. Woolworths is the largest retail store in Australia. They have recently bought the leading analytics firm of the country, Quantium, and with the help of that leading analytics firm, they're applying it every day. On the other hand, deep learning, I'm not separating the attributes. I'm just asking machines, okay, find out the attributes through the analytics and give me the prescriptions, what we are going to do. So that is the deep learning part. Now I'm going to, I think time is very limited, but I will try to demonstrate both of them very quickly, how it is helping us. Now, based on these two types of algorithms, what we are doing, we're developing marketing models. we train data, we collect data, and this training data has to be very good quality. The model we develop, different types of model we develop. For example, in retailing, we apply recency frequency monetary value model, churn analytics model, market basket model, neural networks model. Once this model are developed, we basically identify the best model. And then we present this model in real life applications. So what you see in real life applications are basically like this. Hey, Shahriar, you have bought YouTube strategies. Why don't you buy all other books which are related to your interests? And the mighty Amazon is applying it through its recommendation engine. And this recommendation engine is based on machine learning. And in marketing, we call it cross-selling. So Amazon is using machine learning for cross-selling. And Amazon generates 1/3 of its revenue, 1/3 of its revenue through this recommendation engine. Another marketing model. These are the movies for you. So you have watched these types of movies. Why don't you watch this one? And the Netflix recommendation engine influences 80% of the content we watch on Netflix. And what Netflix is doing, we call it the geotagging. And using this geotagging and using these patterns, they are basically one of the leaders in this particular type of business because they have got one of the most powerful recommendations engines. I am a regular customer of Woolies, that means Woolers, those who are our international audiences. This is the largest retail chain of the country, Australia. And they have sent me this email, earn $10. Why they are sending me $10? Why they are not sending $10 to others? They're applying here a model that I like to apply all the times when I teach analytics to my students. We call it RFM model, recency, frequency, monetary value model. So using these three variables, so you can easily identify who is my best customer, who is my platinum customer, gold customer, silver customer, and we offer money accordingly. We offer loyalty, we offer incentives accordingly. Online dating sites, for example, Match.com is applying 18 variables to match profiles. Simple algorithm they're applying. In the last 20 years, they couldn't do that much. But in the last 5 years, they have done so much of analytics that they are one of the leading platforms in the United States now, just using 18 variables. And those 18 variables means age, gender, income, education, occupation, psychographic characteristics. Once two profiles are matched, they say, congratulations, we have matched, we have got a partner for you. So they are getting a lot out of it, and this is another marketing model they're applying. Facebook ads. We know Facebook's business model is based on revenue, and all the revenues they make by placing the right advertisements in the right profile page. That is Facebook's advertisements. On the other day, I visited Facebook's head office in King Street in Australia. This is basically an advertising office. What they are doing is basically how better they can place advertisements in a profile page. For example, 40-year-old mom who buys diapers 2 times in a week in Australia. They can identify those 40-year-old mom precisely. And that is why Facebook ads are basically killing all other advertisements and newspaper is dying because of that preciseness. And we marketers have wanted that preciseness in identifying customers for so long time. And Facebook is giving us that, but how? 99 variables they're using, including text. The text you are writing in Facebook, the pictures you're uploading in Facebook, all these 99 variables they are using to develop a powerful machine learning algorithm to place it in profile pages. Now, the question is, they are doing it precisely, but often they are using a lot of bias. For example, recently Facebook has advertised STEM jobs, science, technology, engineering, and math jobs. And most of these jobs, they are focusing more into men than women, more into male subscribers than female subscribers. And that's a bias. Similar sort of thing were being applied by Google, Amazon. Now, when we develop these models, this bias is there, this embedded bias is there. Now, where are these biases coming from? Well, the data they are using, all this data they got, the training data they have got in the last 10 years data, that data might be biased. The model they are developing, probably they are not neutralizing some of the variables. So that model is biased, or the deployment can be biased. So as part of this, I'm just showing you a simple demonstration of neural network models. For example, this is a neural network model that I developed for today's session. Predictors are type of products, unit price, promotion, revenue before promotion. Outcome is how much revenue we have increased. So using these variables, I've developed this neural network model using IBM Watson. And if you allow me time, probably I don't have time to go into my real model to show you. It will take some time to load the model, but I can explain it. So in this model here, you see these are in neural networks. Here you see this is called synaptic weights. So synaptic weights indicate which variables are more important. So here the product types and promotions are important, right? So the training database model showed me that my model's predictive accuracy is 82%. And then once I develop this model, I use the same model on my test data. So this is the training data. So I use the same model on my testing data, and it showed my model's accuracy is 87% on testing data. But the problem is I have used few variables. And in this model, all those who are marketing professionals or marketing practitioners, they know in marketing, we have got a lot of other important variables like which channel we have used. Because channel is also an important, and there is no information on the channel here. So without channel, if we just focus on product types and promotions, then it's a problem. We cannot make serious marketing decisions on this neural network model. So these are some of the model-related issues that we can encounter when we develop these models. This is the machine learning, the equation that we generally apply. Here, the B is basically the intercept, it's not the bias. The bias, although in the equation we say this is the bias, but basically we are not interested in this bias. This is the intercept bias. We are interested in overall social and historical biases which are embedded in the data, the model, and also the deployment. In this case, the Guardian said, although neural networks might be said to write their own programs, they do so towards goals set by humans using data collected from human purposes. If the data is skewed, even by accident, the computers will amplify injustice. Amazon recognition, for example, Amazon recognition uses it for surveillance, airport passenger, employment, mortgage decisions. And again, I have developed another deep network learning-based model using Amazon recognition. Again, if I click here, I will go into my model, but again, we don't have probably the time, so I'm not going into my model. The message is basically using Amazon recognition. If we develop a model, because it's basically a facial recognition model, facial recognition type of model, this model has got these issues. It makes mistakes the gender of darker skinned individuals as well as darker skinned women for men. Also, of all the dominant biometrics in use, fingerprints, iris, palm, voice, and face recognition is the least accurate one. So based on this decision, based on Amazon recognition has been used to make a decision who is going to be given parole. So, you know, who is going to be sentenced in law and order. So in the US, they have used it and they have got issues, and finally they are scrapping that type of facial recognition-based model. Now, I wanted to see using this model, I have got my friend Sam and I. So I have got a photo of Sam and I applied that photos to find out whether it can identify both of us, you know. So it creates some issues. Now, algorithmic bias in international media. So here you see the Apple Card. We know the Apple Card is a high profile bias example of these algorithmic things. The Amazon's recruitment, it was a huge scandal because it was just focusing on males. And similarly, we have got in Australia, we have got a great example of RoboDate, and Professor Katina Michael is an expert on that area. So I will leave that discussion to Professor Katina for some other discussions. But these are the types of bias we are facing. So as part of our research in the last 3 years, we have investigated what are the sources of bias. Basically, there are 3 sources of bias: data bias, model bias, social bias. These are the 3 sources of bias we have identified, and we have identified many other sub-variables under these major sources of bias that what we are not going to discuss now, because those are all in our published papers. If someone is interested, you can read that. And as part of this bias, addressing this bias, we have come up with 2 ways to address this bias. One is a priority method. That means before happening bias, what should we do? Before happening bias, when you develop an AI model, first of all, we should ensure the scientific consistency, the scientific accuracy of the model, application consistency, to what extent it is applied to the right audience, right context. We shouldn't overgeneralize. And also, you know, we have got correlation fallacy. If you upload any data in machine learning, it will show some variables are always correlated. But to what extent that are meaningful, that we have to identify. The stakeholder consistency, we really need to involve all the stakeholders. For example, in the context of RoboDate, those people who developed AI in Australia, AI-based models for Centrelink, they didn't involve all these stakeholders. Assurance consistency, if something goes wrong, who is going to be responsible for it? So these 4 consistencies have to be ensured that we discussed in one of our research. If this happens, then what is the post-hoc approach? So as part of the post-hoc approach, we have said that we need to pinpoint what is the problem. Is it data? Is it model? Or is it the deployment? We really need to audit that particular situation. We have to identify the variables. Is it gender, or is it income, or is it the postcode? We need to identify the variables. Then we have to ensure that the model, after identification of the variables, whether the model is working okay or not, the responsible AI model. Analysis of training data, to what extent training data is perfect, we have to ensure that, because if data, we have got a word in business, garbage in, garbage out, right? So if data is problematic, whatever great model we develop, that is not going to work. And finally, after developing the model, when you test it, what is the stakeholders' feedback? All the stakeholders' feedback on our model. So these are the 6 steps we basically proposed and discussed as part of post-hoc approach. Now, the last verse. Algorithms might present risk because they can amplify injustice, they can propagate historical, social, personal biases. Algorithms are black boxes most of the time, and that results in unjust, unfair decision-making. But algorithms can be glass boxes. Can we turn that black box into a glass box? That means transparent algorithm? Yes, we can do that. Their complexity could make it more difficult to challenge decisions because it is a black box. Our decision-making capability can reflect generalization, overgeneralization, automation bias, correlation fallacy. These are some of the things we have found in our research. Automation bias means we tend to rely more on a machine's decisions rather than on our own decisions. So these are some of the consequences we are facing. Yes, they might present risk, but algorithms can transform our lives. They have the capacity to process big data efficiently and effectively. They can make evidence-based decisions with the help of an explainable AI. That means an AI which is based on a glass box, not black box. Algorithms can be diagnosed and improved. Algorithms can lead to better tomorrow if they are deployed correctly. So these are some of the publications that we have got in the last 3 years on these algorithmic biases in IGIM, in JBR, in European Journal of Information Systems. I tried to introduce some in the contribution sections and in industrial marketing management, and probably in the last JBR paper, I discussed a lot on algorithmic biases. So that is because all this research happened because I have had a great team, and that team is led by Professor Ketina. And also I have got some other great members in the team, Kumar Bishas at UOW, Ruan Bandara at UOWT, Shajib Shahriar at UTS. So this is the team we have got to continue this line of research, and we'll keep doing that. Thank you very much, guys. If you have any questions, I would love to take.
Thank you so much, Shahriar. That was such a, I guess, a balanced marketing-based perspective on how AI can certainly be used for value creation, as you said, for precision in terms of marketing efforts, and potentially enhancing customer relationship management. But I do like how you mentioned the challenges associated with embedded social and historical biases resulting in inequality or inequitable access, which I guess our next speaker will pick up on as well in terms of the justice-related elements. And this is such a timely and important topic, particularly as you demonstrated, as organizations have either invested in, as shown in your examples, or are increasingly looking to invest in AI-based solutions. Just on the last slide that you showed, Shahriar, I would like to draw attention to your recent work, particularly the 2022, where you present an integrated framework or conceptualization that articulates the sources of algorithmic bias so well. You did mention them in passing. I believe that work in particular, for the purposes of this discussion, for any of our audience members who are interested in finding out more, sets a really solid foundation for how organizational and other stakeholders, which you mentioned, may understand the dimensions of bias. So, the design bias, contextual and application, and also how we can move forth to encourage more ethical and responsible innovation and marketing-based practices and models. So I want to thank you very much for your research, for your insights. And again, for anyone who's interested, we highly recommend you look at Associate Professor Shahriar Akter's publications, particularly the Journal of Business Research, which deals with sources of bias and this discussion more specifically, in addition to the others. We do hope there will be time for questions today and further discussion into the future, but for now, we will move on to our next speaker, and we are delighted to welcome Professor Olivera Marianovich to the PIT Colloquium. Professor Olivera Marianovich is the head of School of Professional Practice and Leadership in the Faculty of Engineering and Information Technology at the University of Technology, Sydney. Olivera has received a PhD in Information Systems and a graduate certificate in Higher Education from the University of Queensland, Australia, a combined research and coursework master's degree, majoring in Information Systems and Computer Science from the University of Belgrade, in addition to a Bachelor of Electrical Engineering and Honours, also majoring in IS and Computer Science from the University of Sarajevo. Olivera has been working in the higher education sector in Australia for more than 27 years across both business and IT and engineering faculties, where she's particularly interested in applied research and innovative teaching across a range of areas. And she's also passionate about the human side and societal impact of new technologies, such as artificial intelligence, advanced analytics, algorithms, and digital platforms, among many other areas of interest and expertise. Professor Marjanovic has received major national and international grants, recognitions and awards for her innovative teaching and highly applied industry-based research. And she's also actively engaged in numerous activities designed to enhance collaboration and value between industry and academia, which we've spoken about several times in this colloquium. And I could go on here, but instead I will hand over to Professor Marianovich, who'll be delivering a presentation on algorithmic justice in social welfare and other transformative services, drawing from the theory of abnormal justice to present the foundation of a new theory of algorithmic justice that addresses a range of questions. Welcome, Olivera.
Thank you so much for your kind introduction. I'm delighted to be here. I'm honored to have this opportunity to share our work in the presence of people whose work I follow and continue to learn from in my own work. I'm calling from UTS, so for some of you that means calling from the future because it's already the 30th over here. I have very fond memories of Arizona State University. I had a privilege to visit in 2012, and in many ways this is like going back, at least in my mind. So I'm going to talk about algorithmic justice, and my brief presentation today is aimed at both researchers and practitioners. So I'm going to skip some of the references and some of the details of the theory. And for those of you who are interested, that the paper this presentation is based on is available, and it's even in the public domain because somebody posted it on Google Scholars. So I'm presenting the work that was conducted by the three of us. So I'm not taking a full credit. It's a collaboration, intercontinental collaboration with my colleagues, Dubravka Čaček-Kecmanović and Richard Widgen, both from UNSW. This is the essence of my talk. This slide shows everything that I would like to communicate today. So there are different approaches and perceptions of unintended harmful effects of automated algorithmic decision-making. Colleagues perceive this to be a computational problem, or to be a socio-technical problem, or to be a problem in the society because we have inherited societal injustices, and therefore algorithms are actually amplifying what already exists. We take a different perspective, and that is we claim that unintended harmful effects of automated algorithmic decision-making powered by big data and analytics, when used in transformative services, often result in harmful effects, and these effects are actually methods of social justice, or more precisely, algorithmic justice. So to understand this concept of algorithmic justice, we posed 4 key questions. What is the meta of algorithmic justice? In other words, what is just? How do we know what is just? Who counts as the subject of algorithmic justice? How are algorithmic justices performed? And the word perform is based on performative aspects of algorithmic justice, as I will explain. And how might we address and resolve disputes of the what, who, and how of algorithmic justice? Now, our objective is not to answer these questions. This may sound really strange to the PhD students in the audience, if we do have any, because normally we pose questions and then we answer questions. No, our objective is different. We aim to inform and empower the relevant research and practice communities to have a dialogue and then look for their own answers, because assuming that we can actually give answers to these fundamental questions is naive, to say it bluntly. So the rest of this talk is to actually explain different elements of this slide. So we can stop here or we can keep going. So let's keep going and unpack this. So automated algorithmic decision-making powered by AI and big data is impacting all aspects of our life. And without any doubt, there are many positive effects of AI. So this talk is not focused on harmful effects because we cannot recognize positive effects. It just happens that harmful effects are creating issues of social justice that we see are not explored enough. So we just open a further conversation on this topic. So I'm not going to repeat what Shahriar beautifully explained. So we know that algorithms are now used by organizations to hire, promote, fire people, decide who is given access to insurance benefits, credit, even education and scholarship. So all aspects of our life. However, they're creating unintended harmful effects. I didn't want to include the references here because I think the slide would be extremely busy if I'm to list all references that we have found in the multidisciplinary literature, as well as in various reports that keep coming about harmful effects. We use a special term, algorithmic pollution, and have written about this because harmful effects do create the invisible pollution, not in the sense of discharge of harmful particles, but in a sense of new category of social pollution. And this pollution is real, mostly unregulated and spreading, and sometimes our own enthusiasm for these kinds of technology really contribute to generation of algorithmic pollution as well. So what is algorithmic justice? We put forward a key claim that is again based on very extensive literature that harmful effects of this technology are methods of social justice and human rights. There are many different interpretations of this term. When we started writing about it, we discovered that people mean different things by algorithmic justice. So our interpretation is aligned with the same term that is used in social sciences by colleagues such as Cadell, and in design justice more recently by Sasha. However, algorithmic justice, the way we interpret it, is fundamentally different from the same term used in legal studies and criminology literature, where they use the term to describe the use of algorithms in the justice system. We draw inspiration as well as insights from a very broad multidisciplinary literature, Patrick's work included, who is a pioneer and who is leading our discussion about the dark side of AI and powerful technologies that in information systems tend to be celebrated, researched by focusing on the positive aspects. I would like to draw your attention to transformative service research, even though it comes from a different field. The leaders of transformative research happen to be at university at ASU because you have a Center for Service Leadership. We are also informed by the ongoing research and practice, including data activism by the colleagues in the data justice community, data in society, algorithmic justice movement, critical data studies, and many other areas that I did not list here. So we focus on transformative services. Briefly speaking, transformative services are services that transform human lives by having direct impact on the well-being of individuals, communities, and wider society. Now, there are transformative services by definition, by nature. So these are welfare services, employment, healthcare, criminal justice, housing services, the exact services where fully automated algorithmic decision-making is now being widely used. There are other services that are turning into transformative services that by definition were not in this category. However, we focus on these highly sensitive human services and try to unpack what happens when you actually apply this powerful technology. Well, what happens is something that is now very well documented. And I will give you a chance to read this powerful quote. Living inside someone else's imagination refers to actually how people are digitized and subjected to decisions made by fully automated algorithms. And unfortunately, this is also a low power context where service users use these services, such as welfare support services, not out of choice, but because they're forced to, and it's for their own livelihood. So keep this in mind as we continue to explore what happens when these algorithms are introduced here. So in terms of theoretical foundations, we use the theory of abnormal justice. Now, Nancy Fraser, who is the leading theorist who proposed this theory, looked at the traditional theories of distributive social justice and said, well, this concept of equal distribution ought to be challenged because justice is not only about equal distribution of goods and human rights. She said that we ought to question our shared scientific assumption that all of us agree what is just. And we ought to challenge this. And we also need to understand and broaden our perspective who is affected and how it is affected. When we talk about distributive justice, then this is relatively easy because we all can agree what is equal distribution. But when you talk about other aspects of justice, that's not possible. This is not meant to be an eye chart, and I'm not going to go through this slide. I decided to include it because I will make these slides available, and for those of you who are interested in theory of abnormal justice, this is a one-page summary that gives you enough detail to understand different aspects and nodes of abnormality as introduced by Fraser in her very, very influential work. So I won't spend more time on the details, just wanted to introduce this to you. And what she's saying is that we need a relatively stable framework, something that will enable us to have a dialogue about different nodes of abnormality as she defines them in her work. This is what we are doing. So we propose this theory of algorithmic justice by looking at her theory of abnormal justice, and then we reinterpreted it and we extended it, because when it was produced, proposed by Fraser, this was a world where social justice issues created by artificial intelligence were in a distant future. Now we are living this future, and we decided to not only reinterpret but also extend by observing other nodes of abnormality. So this is our proposed framework, and I will take you very, very briefly through a case study that we described in our paper, but this case study is typical of many other cases that we can now see all over the world. So our case focused on universal credit scheme introduced by the UK government in 2013. And as you can see, things have progressed since 2013. One of our co-authors is from UK, by the way, so and had a very deep insight into this case study. So what happened is that the Department of Work and Pensions started building an intelligence automation garage out of welfare robots, if you like, who were deployed and based on deep learning algorithms to improve the efficiency of the welfare transactions. Now, similar systems are here in Australia. We have Robodebt, and I'm really, really delighted to hear that Katrina is an expert in this area. So, Katrina, I'm open to learning from you. So please observe our case study with a critical view, and let's talk about how do we progress our shared understanding, as well as, dare I say, digital activism. So what happened, they introduced a very simple risk-based verification algorithm. And when you look at this is actually very, very simple. So you have medium risk and high risk citizens. Of course, you have low risk citizens where no intervention is required. But in the case of medium and high risk, there are additional steps that have been put in place. Now, what they claim to be the outcome is that this digital transformation has been very successful, because they have made their services more effective and efficient. And they were able to process higher volumes of these services, and therefore cost saving was cited as one of the benefits. Now, there are numerous harmful effects that have been reported, ranging from marginalization to serious mental health issues, including suicide. COVID pandemic made it worse, because all of a sudden people who had never had any need for social welfare support started queuing in order to get benefits so they can actually survive. And in the first month of pandemic, they had over 1.5 million of new welfare recipients, which is a huge volume. And obviously there is a need for technology to improve the experience. However, with this technology came serious unintended consequences. So individuals and organizations started to challenge this implementation. However, there were some key issues they were faced with. So the algorithm was black boxed, and even though you may claim, well, they ought to be made transparent. In this case, it was not possible because the models were provided by the commercial software companies. And they claimed it was an issue of IP, and therefore opening them up was not possible. Now, even people who were using the algorithm were unable to understand and explain the inner working. And unfortunately, they refused to answer Freedom of Information requests to explain how data were obtained and what kind of data were used, either by direct harvesting or acquisition from other sources. So in response, they offered a statement which is at the bottom of your screen, claiming that bots actually didn't make decisions. They don't make decisions. Instead, they focus on everyday repetitive tasks. Now, keep in mind that these are low rights environments, low right context, where people who are marginalized and are experiencing harmful effects, they cannot just walk away. They continue to suffer and suffer more as a result of the practices that are meant to help them, which is a great paradox that is all of a sudden introduced through this technology. So I will give you a moment to read this, and then I will show you one more slide, how we actually analyze this, two more slides, how we analyze this case, and how we can apply this framework of algorithmic justice. So as you read these words, keep in mind that nobody has done this deliberately. So these are organizations that are committed to social welfare. Therefore, whatever harmful consequences happened, they were unintended. However, the system gained a life of its own, and therefore it is harder and harder to actually challenge it. And the solution is not as simple as opening up the black box and then looking at data, because what also happens, these consequences are propagated through the systems of algorithms. So if you are labeled as a high risk in one context, in the context of one service offered by a government, then this label travels with you somewhere else. And you continue to experience harmful effects that all of a sudden it is close to impossible to trace across the maze of different systems of algorithms. So what we identified as a meta of social justice, keep in mind, we are not giving answers here, because saying this is just and this is not just would actually defeat the whole point of having different views of what is a meta of algorithmic justice. So we identified different perspectives that ought to be taken into account, and they could be classified as economic, sociocultural, and political perspectives of justice. For example, political perspective is that people become voiceless, and they even the political powers are taken away even more as a result of very powerful technology that is perceived to have positive effects. And there is a cost-saving perspective that in many different ways would outweigh complaints by some of the recipients of the welfare services. However, when you look from the social justice perspective, harm is harm. So this idea of a balancing casting effects does not really make sense from the social justice perspective, because harmful is still harmful. So saying there is a acceptable level of harm is against principles of social justice. Who counts? That's another maze of a problem, because we are now dealing with datified, they datified individuals, and they perpetually constructed. So within one service they constructed, but as more data are acquired, you actually end up going deeper and deeper into this spiral of datification, even without datifying individuals being propagated somewhere else. And what we are observing is that this is not one-off datification. It's actually, these people are perpetually reconstructed over time, with very, very little chance of actually getting out of this perpetual circle of reconstruction through datification. Now, we found, in terms of how algorithmic injustice is performed, is that ongoing datification and technological inscribing are starting to perform or starting to create new worlds. So no longer datifying reality is meant to represent the new world, the existing world. What actually happens is that it starts to perform new worlds in unexpected, and we also claim unknowable ways. So finally, the fourth node of abnormality, that is, how do we address disputes about the other three components of algorithmic justice, opens up an opportunity for a new kind of information system, because there is the need for a more effective society-wide discourse on algorithmic justice, because the current conversations that we have in the society are not fast enough, not suitable enough for the new reality that requires both government but also grassroots organizations to have a perpetual and ongoing dialogue about the unintended consequences, because in spite of best efforts, many of them cannot be predicted and therefore need to be observed by people on the ground. So some concluding remarks. I find this statement from the special rapporteur Philip Alston on extreme poverty and human rights to the United Nations really, really disturbing, because it talks about a digital welfare dystopia. There is a question that I invite all of us to think about. What does mindful appropriation of digital technologies in the provision of welfare services look like? We are not able to offer the answer. However, we claim that engaging with the questions, the key questions of algorithmic justice, require knowledge, courage, compassion, and above all, our shared humanity. And I say, cheers to our shared humanity.
Thank you so much, Olivera, for that fascinating presentation and very inspiring ending there. Based, as you mentioned, on your European Journal of Information Systems article, which I have popped in the chat for anyone interested, but also your other articles, which equally contribute to this discussion. Such fantastic work, as you can see in the chat now, and yes, congratulations, where you're effectively challenging the way in which we may consider unintended consequences of automated algorithmic decision-making in the context of transformative services. I believe it's it's valuable that you question existing and dominant social justice theories and suggest that we need to extend our understanding of justice, not only thinking about in terms of equal distribution of justice and rights, which is quite restrictive, as you note in your work, but through the abnormal justice lens. Having read some of your work and hearing your presentation now, while your research is a significant contribution to IS research, specifically the way in which we think about large-scale systems, I can also see how you may also contribute and the work may be more applied to other contexts and other disciplines. I just might reflect briefly on your talk here. I also feel that in extending Fraser's model of abnormal justice, your work is essentially providing us with a helpful means of identifying and articulating the key domains of justice contestation. So there is some alignment with what we heard from Shahriar, and it's quite complementary to that organizational focus of Shahriar's research and the sources of bias that he spoke about. And then we take those ideas and apply them to society level systems and services, discussing the effects and implications more specifically, and how, as you mentioned, you resolve disputes within your theory and those questions. I think a final observation that I'd like to say here is there seems to be an evident link with your proposed theory and the potential for defining guidelines or principles that can be operationalized to extend that, or operationalized to, I guess, apply that theory in practice. And I think there's certainly promising future research directions that I'd love to discuss with you and explore further. And that provides us with a direct link as well to our next talk. So I just want to say thank you once again, Olivera. I'm energized thinking about future discussions on this topic. We will, however, just in the interest of time, move ahead and welcome our final speaker for today, Associate Professor Patrick Mikalef. Patrick Mikalef is an Associate Professor in Data Science and Information Systems at the Department of Computer Science at the Norwegian University of Science and Technology. In the past, he has been a Marie Skłodowska-Curie postdoctoral research fellow working on the research project titled Competitive Advantage for the Data-Driven Enterprise. He received a Bachelor of Science in Informatics from the Ionian University, his Master of Science in Business Informatics from Utrecht University, and his PhD in IT Strategy from the Ionian University. In terms of research interests, he focuses on the strategic use of information systems and IT business value in turbulent environments. And he has published work in international conferences and peer-reviewed journals, including the Journal of the Association for Information Systems, the British Journal of Management, Information Management, the European Journal of Information Systems, and Information Systems Frontiers. Associate Professor Patrick Mikalef will be speaking on the topic of responsible artificial intelligence from principles to practice, covering some of the latest developments in the field of responsible AI as documented by academic literature and reports by international organizations. And he'll also be focusing on ways through which we can effectively move principles into governance practices. Welcome, Patrick, and thank you so much for joining us today. We do appreciate it's quite late on your end.
Yes, thank you very much for the invitation and for the great introduction. Thank you very much, Katina and Robo, for that. Yeah, so really interesting talks from both Shahriar and from Olivera. This last talk, I think, kind of is an umbrella talk, to put it this way. It covers a little bit of every aspect of this notion of responsible AI and how do we develop algorithms and AI that kind of conforms to our ethical standards and what we expect from algorithms. So just to give a brief overview of where this work came from, it's been a few years now where we've been looking at what is the business value of novel technologies, and obviously in the last few years, artificial intelligence has been the one that has kind of dominated interest. And usually when we introduce new technology into how we work, how we do business and so on, we tend to look at the positive sides of any technology. So this kind of made us think, along with some colleagues, about, okay, what can we gain by looking at the dark side of technology? And is there something valuable in doing so? And this was particularly relevant in the case of artificial intelligence. Most of what we see in popular press and blogs and posts and proponents of new technologies usually focus on the bright side of technology. So what can we gain from it? In which ways can it make us more efficient, more productive, happier, healthier, and so on and so forth. And I think this is pretty evident when you take a glance at the covers of some popular magazines, and even some like non-traditional technology-oriented magazines like The Economist or Time. And in the last few years, at least in the research point of view, we've gone a step further, thinking, okay, if AI can introduce these benefits to business and to organizations, how exactly can we manage this change? And I think that this is an age-old debate of how do we effectively manage technology and make it do what we want it to do. Nevertheless, what we tend to see, at least with every novel technology, and specifically and especially I would say with artificial intelligence, is that you tend to have a lot of these negative effects, as were presented also in the previous presentations. I can give some examples that are pertinent to the case of artificial intelligence. So, for example, you might have heard an early attempt by Microsoft of releasing this chatbot on Twitter. The idea was quite nice. You develop something that learns from the interactions with other humans. It gains as input what people teach it, and it kind of builds a knowledge base on this and becomes more proficient in communication. But what happened is that very quickly, I think it was less than 24 hours after it was launched, this chatbot started to become racist and started to have tweets that were really, really inappropriate in many different perspectives. And Microsoft was required to shut it down. So this is like a very prominent example of AI gone wrong. And simply, this is because you develop something that has a life of its own in its own way. So you can't really control what the outcome would be, simply because it learned from the environment, and the environment can be quite unpredictable. So there's quite a lot of unanticipated or negative effects of using technology, especially new technologies such as AI that haven't been tested before, at least in these kind of contexts. They tend to go from theory into practice, and now we see the first, at least, practical applications that are on a large scale. Other cases include, for example, Amazon's AI tool that was supposed to help with recruitment. This was scraped because of bias concerns. So what Amazon did is that they built the model based on prior historical data. This prior historical data tended to advantage male candidates. So you had a model and an AI algorithm that kind of replicated this decision-making. So it reinforced a long-standing tradition of being disadvantaging female candidates or minorities. Another concern when it comes to artificial intelligence is the issue of descaling. So being replaced or displaced, or being displaced by machines. Something that would take typically a very highly skilled professional to do is done by a machine, or a machine that is controlled by a semi or an unskilled worker. We can see a lot of these applications, at least early ones, in the healthcare sector, for example, where you would need a really highly skilled specialist who would be able to read, for example, different images come from radiography. Now a lot of this is being done by machines. It isn't done to the point yet where the radiologists are being redundant, but we see that there is a trend, at least of people that have a skill set, their job being replaced by artificial intelligence. So there's a lot of changes that are introduced, a lot of disruptions, a lot of unanticipated consequences. And this is simply because this technology is quite new. It's quite powerful in what it can do. There's many different potential applications, so there's many places where things can go wrong. What we sought to do, at least a couple of years ago, when we were thinking about this with some colleagues, including Ales Popovic, Jenny Lundström, and Kieran Conboy, is that we thought we should propose a special issue called on looking at the negative or the dark side effects of artificial intelligence. This was not just to emphasize how bad the new technology is, but mainly to see where things go wrong, why they go wrong, and what we can learn from these. Because when everything goes perfectly well, you don't really learn anything about it. So it was a good opportunity to be a bit more critical about this new phenomenon and see what we can learn and how this can be used as a way of advancing research and practice. This special issue was concluded a couple of months ago. We published also the editorial. It was online, I think, a month ago or so. It's titled Thinking Responsibly About Responsible AI and the Dark Side of AI. And this idea of responsible AI kind of flowed naturally from this discussion that we had. So, okay, if we can learn something about how AI has gone wrong, how do we term this? What do we call it? And obviously, it linked pretty well to this growing, let's say, stream of thought around building AI that is responsible. I'll say a few more words about this and what responsible AI is, but I think it's nice to trace a little bit back to its roots. So thinking about what the ethics of artificial intelligence are is not something new. It's something that we've been thinking from the time when AI was quite literally science fiction. So, for example, from the 30s, the 40s, there has always been concerns about if we develop machines that can think, that can feel, that can reason, what are the implications of that and how do we deal with it? There's been quite a lot of work since then, mostly from a philosophical and ethical point of view. But over the last at least 5 years, maybe even a bit more, we've come to a new spring of artificial intelligence. We've had the data available, we've had the processing power, we've had the sophisticated algorithms. So there's a unique set of, let's say, circumstances that have coalesced. And now we have the opportunity to actually implement these things that were once science fiction. So this idea of ethical AI or AI that is based on specific principles is becoming much more relevant now. And now we're dealing with real world phenomena that have some implications on this. And as a result of this, there has been a large debate, and this is growing consensus about what this notion of responsible AI is. I like this quote, which mentioned that responsible AI is a framework that documents how a specific organization is addressing the challenges around artificial intelligence from both an ethical and legal point of view. And this comes from the European Commission report. I'll say a few words about this in a bit. And it's basically a way of looking at what are the unintended or negative consequences that you could possibly have by using or implementing AI from a holistic point of view, like who and what are the things that it influences, and how can you actually deal with this in different phases of developing artificial intelligence. So a few questions that responsible AI tries to answer, at least its framework, is what should AI do and how? Who decides? How should we deal with ethical dilemmas? How do we make these decisions? Whose values should be prioritized? So there's quite a lot of things that are encompassed in this notion. There has been also quite a lot of work around this idea of responsible AI. This is from a report from the Berkman Klein Center in Harvard, where they try to map out what are the different work that has been done on ethical and responsible AI throughout the last few years. And this just shows a timeline from 2018 until up to almost today, where you see that there have been reports and publications around responsible AI from not only from academia, but also like from civil society, from government institutions, from intergovernmental organizations, private companies, and so on. We have reports from like the OECD, the G20, IBM. So there's a really a big variety of different entities contributing to this discussion about what responsible AI is. How should we address this issue of responsible AI? The one that I'm drawing a little bit reference on now, and I'll say a few more words about it, is this high-level expert group report from the European Commission. This was published, I think, about 2 or 3 years ago. It's basically a task group that was commissioned from the European Commission to think about what are the implications of artificial intelligence, where things can go wrong, and what are the key principles that AI should be built on. And they came up with this framework that has 7 dimensions. It looks at things regarding like accountability, the human agency and oversight, the robustness and safety of AI, the privacy and data, governance, transparency, and non-discrimination, and societal and environmental well-being. So it looks at how AI should be developed from different points of view. If we zoom into one of these points, for example, transparency, what they do is they document in this report sub aspects within this principle that need to be addressed. For example, there is a need, according to the group, for traceability, for explainability in algorithms, for communication. So what they have been trying to do and communicate in this report is that when you're developing AI, these are principles that you should follow when you're developing an AI solution, or you should think about. So one could think about these as being, let's say, high-level principles or goals that one must achieve or take into account when developing AI. Similar things have been done also by private companies. For example, Google has this report and they renew it every year. So this is from the latest, from the 2021 one. I haven't checked if there's an updated version of it. Google also positions it in the same way. They talk about principles. They're basically things that are best practices to do around AI in order to make sure that solutions don't have unintended consequences. And when we look at responsible AI in IS, so far we have quite a lot of studies that focus on, for example, specific aspects of responsibility. For example, we talked about bias or accountability or transparency. But mostly we perceive them as high levels, as a set of high-level principles that should be followed. One thing that hasn't been discussed and is usually quite central in the discussion of information systems research is how exactly do we incorporate this into governance? And what governance basically entails is how exactly do you manage, do you orchestrate the project lifecycle of a technology from start to finish, and then maintaining it. And one of the key issues here is that when we talk about governing technology, we usually talk about different phases of technology development. We usually talk about different actors and different levels. So we talk about, for example, governance at the strategy level, at the operational level, at the executive level, and so on. So we differentiate quite a lot who does what at what levels and so on. So we have a long tradition about how do we manage technology. But what we haven't done so far is look at, when we take into account these principles, how exactly do they change how we govern technology? And this is something that is an ongoing part of research. I'll talk a little bit about a little bit of the past in terms of governance and technology management. This presentation isn't to conclude something about a specific work that has been done, or at least a specific article, but it's more of ongoing work in many different directions, and hopefully can spark some ideas from your side too. So the idea is, how do we go from these high-level principles into governance practices? And I think it's interesting to trace back a little bit the notion of governance and IT governance, because IT governance has been around for more than 30 years. It's been discussed in IS literature, and it's basically defined as a process that ensures that effective and efficient use of IT in enabling an organization to achieve its goals. And this is definition by Gartner. When we look at the IS literature, we typically have quite a lot of work that focuses on three main pillars of what governance is. So governance usually, IT governance comprises of structures. So who is responsible for what, at what level, who has the responsibility for different things within the organization, who is responsible for the technical infrastructure, for deciding the project lifecycle, if KPIs are met and so on. We usually have processes. So how things are done, how do you execute something? So how exactly do you target data, for instance, or how exactly do you ensure that algorithms are working as they should? And then you have relational mechanisms, so the relations between the different people within and throughout the organization. And this is from a study in 2006. It's quite foundational. I think a lot of IS research has built on this. And when we look at some more recent literature, for example, this article published in 2013 by Talon, Ramirez, and Short in JMIS, they look at information governance. So basically looking at the subset of IT governance, mostly due to the advent of big data at that point. Again, we see that we have this like structuring on three different pillars: the structural practices, procedural practices, relational practices. And obviously there's things that enable and inhibit being able to enact governance and some effects or consequences of it. What's interesting to see, though, that when we talk about AI governance in particular, there's a lot of different perspectives around what AI governance is. So if you ask a data scientist what data governance is, you will probably get something, AI governance is, you'll probably get something as the following. So this is an article published by Microsoft, and it has to do with the software engineering learning process for machine learning algorithms. We see here that they have a sequence of different steps. So governance is seen as a sequence of activities that follow one another, and they define within each of these a set of activities or subtasks. When we look at AI governance from a more, let's say, technology management perspective, you might recognize this is an adaptation of the CRISP-DM model. So basically a standard model that has been used for many years on data mining, which again defines a series of tasks. But this specific one has been a little bit tweaked to accommodate the case of AI. So here we can have a sequence of different steps that need to be considered. These steps have a series of subtasks underneath each of these. And then what we can do is we can start mapping the different steps with the different people that are responsible, different roles. So you start to get a little bit of a view, okay, this is the process. We also have the roles, who is responsible for something, who is accountable, who is involved in things. So we start plotting things and getting a sense of how exactly an AI project is governed. What I want to kind of like convey here is that when we talk about AI governance, at least for now, there is this very fragmented perspective around what governance is around AI. We have a lot of different actors, we have a lot of different perspectives. There isn't any really consolidated view, and it becomes increasingly more complex when you introduce these high-level responsible AI principles. So when we're talking about responsible AI governance, this asks the question, how should AI basically be managed responsibly? So when we take all these perspectives, data scientist, of the person that is developing, of handling data, or developing algorithms, or actually the one that is testing it, how exactly do we incorporate these principles in order to make sure that the end product is something that conforms with the high-level principles that have been defined from before? Second, then, how do we consolidate these different perspectives? So how do we exactly understand what needs to be done from each involved stakeholder? And looking back at the responsible AI principles, what principle concerns whom, at what level, through which way, it becomes a quite complicated question. What implications does this have for different stakeholders? So this opens the question of how exactly does this change the work that people are doing? For example, if there is issue of bias within a specific algorithm that performs a certain function, how, if we think responsibly, does this change the practice even from data collection, data tagging? How exactly do you include people? How do we actually think of bias? Because bias can also be a bit, you can focus on different things depending on subjective aspects of which culture you're from, your background, and so on. So how does this change the process for different relevant stakeholders? And the last question, which I think is very interesting too, is this an extra obstacle or is it an opportunity? And I tend to think that it's mostly the latter. I think it's an opportunity. So I think that the AI gone wrong examples kind of signify that if you are not careful with what you deliver and what you deploy, you'll probably run into a lot of trouble. And people are becoming a lot more aware of how their data is handled, how companies are using this data for different purposes, for decision making, for marketing, and so on. So being transparent, being open, being able to communicate what you are doing and showing that you're doing something in a responsible way will most likely have some positive effects down the road. So there's quite a lot to be done here. Currently, with my group, we're working on trying to define a notion of responsible AI governance, what it comprises of, and how we can actually measure it. This is a quite big challenge because it's multi-dimensional and concerns a lot of different actors. And then looking at what is the effect of doing so. Does it really slow down things? Does it make it more convoluted, more complex? Does it create more challenges for companies to actually deploy their solutions? Or is it something that in the long term has a positive effect? And this is something that we're focusing on currently, looking both on certain case studies and looking also on a large sample of different companies that have started to adopt it, at least partially, responsible AI governance practices. So with that, I will conclude the presentation, and thank you very much for your attention.
Thank you so much, Patrick. Excellent questions to end off with there. I wanted to thank you for your insightful presentation, speaking to so many themes, but predominantly to the importance of responsible AI, of integrating ethics and values, which have been a common thread throughout this series, certainly. I think the conversion of principles into concrete practices or tangible governance practices and corresponding AI designs is so crucial, as you mentioned. So we're dealing now with these real world technologies and systems. We're no longer within the realm of science fiction. And as you were speaking, I was thinking about certainly the question you asked, is this an obstacle or an opportunity? And that was one of my questions that I would have been posing to the panel, but I think we're out of time for now. And I was also thinking, how do we operationalize these theories, these principles, and so on to achieve the desired outcome, which in this case is the goal of responsible AI, or is it? And how we actually govern AI. So I often think about what's required during that translation process from principles to practice that you mentioned, whether new methodologies, frameworks, or techniques are required, and what that would imply for industry and what's currently in existence, or whether we can somehow leverage existing methods instead for that desired outcome. And I won't share my thoughts here because then I'll go on for quite some time. But rather, Patrick, I want to go back to your emphasis on the dark side, and I did pop a link to your editorial in the chat window. So that certainly highlights significant areas for future research and encourages further thought about the unintended consequences and negative perspectives, and we'd like to thank you for that work. I think it also that alternative lens through which we can consider responsible AI through your editorial. So you called for the dark side lens to be applied in achieving responsible AI is so essential, particularly for defining what dark side means. So it's not dark side from a dystopian view, but dark side in terms of helpfully preempting or preemptively addressing unintended consequences. So for everyone here, I highly recommend that editorial and the special issue. Thank you so much for joining us, Patrick. Katina, we are out of time here, but I would like to invite you for some brief thoughts, but I'm certain, or at least I hope, that we will continue discussing these themes introduced by our speakers beyond the session. There just seems to be so much to work through. Do you have maybe a succinct reflection?
I do. Shah, thank you. Olivera, thank you. Patrick, Mikalef, thank you. What an end-to-end day this was today. It just makes me realize how much more we have to consider starting earlier in that process of design to ensure that we don't fall into the same common and known biases. So how do we do that? Through responsible innovation. I would just want to say thank you again. I invite all our speakers actually to come back to ASU for sabbatical. Some of you the first time. There are great people like Eusebio Skornovaca who are in the business and management domain, who have cross-disciplinary qualifications that would love to work with you, as we all would in the School for the Future of Innovation in Society. So with those words, back to you, Roba.
Thank you, Katina, for your reflections. And that brings us to the end of our session. I believe today that our speakers have provided us with what is seemingly a comprehensive narrative around algorithmic bias as a concept, the requirement for theory in addressing questions of algorithmic justice and unintended consequences, and also ending off with that the significance really of translating principles to practice in the context of AI and what that means for both organizations and I think society at large. And we certainly look forward to building on these topics and themes beyond this session and determining how they relate to our previous session on AI and the public interest, which covered numerous perspectives also from an information systems perspective. My co-host Katina Michael and I would like to thank our guests for today, Associate Professor Shahriar Akter, Professor Olivera Marianovich, and Associate Professor Patrick Mikalef. And I'd also like to express my gratitude to Katina and once again to Melissa Waite and Anna Reed from Arizona State University, and also to our live attendees for joining us. As usual, the recording for this session will be available on the School for the Future of Innovation in Society's YouTube channel. Have a great day, everyone, and we look forward to seeing you at the next session of the PIC Colloquium. Thank you.